Hey guys, Mr. Wilson here. Today we're going to talk about solving absolute value equations. At the end of this video, you should be able to set up both equations to find the solutions to an absolute value equation. Okay, so a reminder that absolute value is a number's distance from zero. Okay, and it's important to know its distance because that way we realize that the number cannot be negative, as distance can't be negative. Okay, no matter which direction you're running, you're going to be running a distance. So I'll run a mile left, or if I want to run a mile right, still running a mile. Cannot be a negative mile. Okay, an absolute value equation is an equation that has a variable inside the absolute value bars. Okay, just because it has absolute value in it somewhere doesn't make it an absolute value equation. It has to have a variable inside the bars. Okay, so let's look at our first example. It says the absolute value of x equals 5. This is what you should say to yourself when you see this problem. You say the absolute value of what numbers are equal to 5. Numbers, that's bolded, but it's only one letter. Okay, so we got to say which numbers are 5 away from 0. Okay, so again, I put the S in bold to emphasize that typically an absolute value equation has two solutions. This is because there are two numbers that are 5 units away from 0. Okay, obviously 5, and just a little less obviously, negative 5. On a number line, those two numbers are 5 away from 0 in either direction. Okay, however, the expression inside absolute value bars are usually a little bit more complicated than this. Okay, so it actually takes some algebra more than just a little bit of thought and reasoning. So let's look at this equation. We have the absolute value, or they're asking us to solve the absolute value of 3x equals 18. We know that the two numbers are 18 units away from 0. And we know that those two numbers are going to be negative 18 and 18. Okay, therefore we need to find out what value will get the expression inside the absolute value bars to equal those numbers. To do that, we write two equations. Okay, and here are the equations. They're based off of these values that we just talked about here. We said that they're 18 away, and we said the two numbers were positive 18 or negative 18. So we can say either that 3x, and the expression inside the absolute value bracket, is 18, or that 3x equals negative 18. Okay, and then we solve each of those equations to find our solutions. In this case, so 3x equals 18, we would divide both sides by 3 to get x by itself. We could say that x is 6, 3x equals negative 18, divide both sides by 3 here, and we find that x is negative 6. Okay, so in this solution, our answers are 6 and negative 6, and they're opposites of each other, and you'll notice that they were opposites of each other in the first problem as well. They are not always opposites. Okay, let's look at this one. Absolute value of x minus 4 equals 7. So again, we have two equations. We can say, well, x minus 4 could equal positive 7 because the absolute value of 7 is 7. Or x minus 4 could equal negative 7. So those are our two equations. And so we can set it up, x minus 4 equals 7, x minus 4 equals negative 7, and solve both equations. Add 4 to both sides, I get x equals 11. Add 4 to each side, and make sure you're paying attention because a lot of people will see absolute value and say, I want opposite numbers, 11 and negative 11. Doesn't work out this way here. We have x equals negative 3. Okay. So setting up the equations so that we have the positive and negative outcome and solving each of those individually is how we approach these absolute value problems. Okay, at the top, notice this problem has a number outside the absolute value bars. Before we write our two equations, we need to isolate the absolute value expression. Okay, what this means is we will not make two equations until we get just the absolute value bars on one side. Okay, in this case, we need to divide both sides by 2. We do not distribute the 2. You do not distribute to an absolute value bracket. Okay, do not distribute to the absolute value brackets. Okay, so here we are. We have absolute value, 2 times the absolute value of x plus 7 equals 18. Before we start, again, we want to get the absolute value brackets by itself, so we'll divide by 2, and we'll be able to say the absolute value of x plus 7 equals 18. Make sure that's all in there. Okay, good. Okay, and so our absolute value equation, our new absolute value equation, will be the absolute value of x plus 7 equals 18. Okay, and now that the absolute value expression is isolated, there are no numbers outside the bars, we can write our two equations. We can say that x plus 7 equals 18, or x plus 7 equals negative 18, and then solve both of those. So here if I subtract 7, I get 11, and here if I subtract 7, I get negative 25. Again, make sure you're paying attention to actually do this math rather than just say 11 and the opposite. Okay? Alright. I'm going to do, which one? I'll do the second one. I ask you guys to do number 1 for me. Okay, let's look at the second one and follow that with me before you do the first one. Okay, so here we go. Look at number 2. We have 10 minus 3 times the absolute value of 1 minus x equals 4. So first we want to get rid of the numbers outside the absolute value brackets, and it's important here that we're going to treat this whole thing like a variable. Okay, we're going to do everything to get that isolated. So the first thing for this problem, just as if it were 10 minus 3y, let's say, I want to subtract 10 from both sides. And when I subtract 10 from both sides, I'm left with negative 3 times the absolute value of 1 minus x equals 4. Okay. Oh, sorry. I said 4, but 4 minus 10 is negative 6. Double check myself there. Okay, so negative 3 times the absolute value of 1 minus x equals negative 6. From there, I'm going to divide both sides by negative 3. I need to get rid of that negative 3, and remember, I cannot distribute to an absolute value bracket. So 1 minus x, the absolute value of 1 minus x equals 2. Alright, so from there, what I'm going to do is I'm going to write my two equations. The absolute value of 1 minus x equals 2, so that means 1 minus x equals 2, or 1 minus x equals negative 2. And then I'll solve both of those. So subtract 1 from both sides here, negative x equals 1, and that means that x will equal negative 1. Remember, we do that by multiplying by negative 1 or dividing by negative 1. They have the same outcome here. Okay, next problem, we subtract 1. Notice that the steps are always really going to be the same when you're solving these two equations, just because you'll have the same numbers around your variable. But the outcome will be different as the other side's different. So x equals 2. So x equals negative 1 and 2. And those are our two solutions. Okay, remember to do that same thing for the first problem. Get the absolute value bracket by itself, and then make two equations and solve both of those equations, as we did here. Okay, equation 1, equation 2. Alright, absolute value equations do have special cases, and so one of those special cases, we'll see those special cases here. When you isolate the absolute value expression, in this case, let's look at it. We have 13 plus 2 times the absolute value of x plus 8 equals 5. And so as we go to solve this problem, we want to make sure we get the absolute value by itself before we do too much. So I'm going to subtract 13 from both sides. And that gives me 2 times the absolute value of x plus 8 equals negative 8. And then I'll divide by 2. And so when I divide by 2, I get the absolute value of x plus 8 equals negative 4. Okay? Alright. Many people will just automatically move on to making two equations. But think back to what I had you say at the beginning. Which numbers are, in this case, -4 units away from 0? If you think about this situation, or if you think about this situation is impossible. Remember, I said if we run 4 miles right and 4 miles left, it's still 4 miles. There's no such thing as a negative distance. Okay, so if we ask ourselves which numbers are a negative distance away from 0, there is no such thing. Therefore, this equation has no solutions. Okay, but before you can say no solutions, because remember that you really want to have no solutions is not an easy out of a problem. Okay, you want it to be no solutions. Before you can say no solutions, you must check the absolute, or you must isolate the absolute value first. You have to always get the absolute value by itself before you say there's no solutions. For example, let's look at this last problem. Here we have 6 minus the absolute value of 3 plus n equals -1. We see that there's a negative number here. Okay, but before we say, oh, negative number, no solution, we have to try to solve it, or try to isolate the absolute value. So I'm going to subtract 6 from both sides. Negative absolute value of 3 plus n equals -7. Okay. Notice that my absolute value is still not by itself. I have this negative here. Remember, that's like -1 out here. And so I'm going to times both sides by -1. And now I have the absolute value of 3 plus n equals 7. Okay. And now my absolute value is by itself, and it equals a positive number. Okay. So even though it started off with a negative, when we will not call it no solution until we isolate the variable by, or the absolute value bracket by itself. Okay, and then once we do that, then we will break it to two equations and solve it. Okay, so I'm leaving that for you to finish. Break this into two equations and solve it. So finish this problem and this problem for Monday when you bring in these notes. Okay, so now hopefully you know how to set up an absolute value equation and solve it. You know the special cases, and you're good to go. See you guys.